Hey, section 8.5, the law of sines and the law of cosines. So up until now, we have exclusively been working with right triangles and sine, cosine, tangent. Those with rectangles is right triangle trigonometry, so Godot. Sine and cosine can be used also with non-right triangles, but the formulas are a little more involved. So this section is going to look at how and when you use those. So when the first requirement is that it's a non-right triangle. Well, it's not a requirement, but if it's a non-right, you can't use sine, cosine, or tangent. So you kind of have to revert to one of these. So let's start with the triangle ABC and the triangle and construct the altitude or the height from angle C to line segment AB. So we have two triangles, the one on the left and the one on the right. So first with the triangle on the left, the blue triangle, let's do the sine of the triangle. So sine of angle A will be opposite h over hypotenuse B. For the triangle on the right, the red triangle, let's do the sine of angle B. That again, opposite over hypotenuse. So h over a. Now, triangle on the left, the blue triangle, let's solve for h, multiply by b. So b times sine of a equals h. The triangle on the right, the red triangle, solve for h, multiply both sides by a. A times sine b equals h. So you see here, both sides equal h. If both sides equal h, then substitution, both sides equal each other. So b times the sine of a equals a times the sine of b. So now a little bit of algebraic finagling manipulation. Let's divide both sides by b. That cancels the b's on the left. Okay, those go away. On the right, a times the sine of angle b over b. So now let's also move the a over. So let's divide both sides by a as well. On the right side, the b's cancel. So the a's cancel out. And now you have the sine of angle A over little a equals the sine of angle B over little b. And this can be generalized by the same argument, sine of angle C over little c. So this is the law of sines. Sine of big A over little a equals sine of big B over little b equals sine of big C over little c. But here's the catch. While they're pretty easy formula to use, you need opposite information. So, for example, you need both angle A and side A. Or you need both angle B and side B. Or you need both angle C and side C. So you need one of those pairs of opposite information, an angle and its opposite side. So the law of sines can be used pretty easily when we have opposite information. When you don't have that information, you cannot use the law of sines. You have to resort to the law of cosines. Now, the law of cosines, I'm not going to go into the proof. I'm going to go into how you construct it, okay? So let's start with little a squared equals. If you have little a squared, way over to the right, you need cosine of big A squared. Now you need to fill in the middle information. So A squared equals, you're going to do a Pythagorean theorem looking thing. A squared equals B squared plus C squared. Now it's not the Pythagorean theorem. I said a Pythagorean theorem looking kind of thing, okay? So Pythagorean theorem, then minus 2 of those letters, B and C, then times cosine A. Let's build that again, but with B and little b and big B bookending or on the outside of the formula. So little b squared equals, over to the right, cosine big B. And now fill in the middle. B squared equals to a Pythagorean theorem looking thing with the other two letters. So B squared equals A squared plus C squared. Then minus 2 of those letters times cosine big B. So for the third variation for little c and big C, pause the video, try to write it, then start the video up, see how it did. So little c squared equals, over to the right, cosine of big C. Then fill in the middle. The other two letters to a Pythagorean theorem looking thing. A squared plus B squared minus 2 of those letters, AB times. Now, it's not necessary to use all three at once, but to construct the equation you want based upon the information you have. So let's look at some examples, okay? So all of these are non-right triangles. So using law of sines or law of cosines. Finding FG. So FG is opposite of angle H, so that's little h. We have angle F is 39. The 40 opposite angle F is little f. And we have opposite information. We have angle AF and side F. So opposite information, sine of big F over little f. We're trying to find little h. So sine of big H over little h. So you have opposite information, you can use law of sines. So start plugging in what you know. Angle F is 39 degrees. See, little f is 40. And angle H is 32. And little h is what we're trying to find. So to solve this, you could cross multiply. So do that. H times sine of 39 degrees equals 40 times the sine of 32 degrees. To get h by itself, divide both sides by sine of 39 degrees. So 40 times sine 32 all over sine 39 degrees. And to find h, or fg, just plug what you have into a calculator. To be careful, you have fractions. You want to use parentheses around the fraction. So when you plug it into a calculator, the calculator is going to add in parentheses around the angle measures. So you want to add in parentheses a set for the numerator and a set for the denominator. So this entire amount on top divided by this entire amount on the bottom. So when you find that, when you plug it in, just be careful. Remember, the calculator is dumb. It'll do exactly what you tell it to do. So make sure you tell it to do the right thing. The calculator has no nuance of its own. Okay? So it comes out to 33. Did they tell us to round? They don't tell us, so let's go through 33.682 degrees. And the calculator is stupid. You have to be a coherent, intelligent individual and use your consciousness to tell this exactly what to do and what you want it to, what you think is implied. This thing needs explicit instructions, okay? Take a look at this one, finding xz. So we have the 30 opposite angle x, so that's little x. We have 35 opposite angle z, that's little z. We're going to find xz, that's little y. So we don't have opposite information. We then have to resort to using law of sines, okay? Oh, sorry, law of cosines, duh. We don't have opposite information, so we have to use law of cosines. So let's construct our equation. Y squared equals, then over here, cosine y, so there's your bookends, little y and big Y, and fill in the rest. So the middle, a Pythagorean theorem looking thing, minus 2xz times. So start plugging everything in. Y squared equals, see x squared is, x is 30, so 30 squared. Z is 35, so 35 squared. Again, x is 30. Z is 35. Then cosine of 110 degrees. Now here's the nice thing about this setup for law of cosines. Y squared equals all that. Or square root both sides. Y equals the square root of all of that. Pretty nice. So then y equals, oh boy, that's really balanced. Okay, then plug it all in. So square root 30 squared plus 35 squared minus 2 times 30 times 35 times the cosine of 110. And we get 53.322. Is that what I have in my notes? Oh, to reset. Okay, let's. Good deal. 53.322. Alright, just making sure there. 53.322. So when you have the side angle side setup, it's pretty simple. Just square root everything, get your answer. Take a look at the next two examples and check by complete notes. But I want to first look at the measuring a t a little closer. We have, see, s equals, bring you down, okay. So s equals 13. We have t equals 7, and we have r equals 11. So we have side, 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 three sides. We're trying to find an angle. So trying to find an angle means we're using an inverse trig ratio. So let's set it up like we normally do. So we're trying to find the measuring of t. So you have little t squared. On the other side, cosine big T. Fill in the middle with a Pythagorean theorem looking thing. R squared plus S squared minus 2RS times cosine T. So then plug in everything no. T is 7. R is 11, S is 13, R is 11, S is 13, times cosine T. And you got to solve for angle T, that measure. So, going from here, using your algebra skills and inverse cosine, solve for T. And I'm not really a betting man, but I can bet if you make mistake, but 95% confident where you made the mistake. And if you made the second one, I know where the second one is also. So take your time solving this. Make sure you're careful with your algebra, okay? So take a look at those, check them until I complete the notes. I believe there's the example on the next page. Complete that also.